Okay, so we choose forklift as our man-made structure for us to study the structural analysis. This is because forklift is a very important topic of interest for engineers, because when we study the structural analysis for forklifts, we can see the relationship between the loads, forces, and also the structural elements. This is because forklifts are used to carry loads of different weights, sizes, and also shapes. So this can result in uneven distributions and also dynamic forces, which call for strong structural design for us to maintain the stability and also to avoid any mishaps. So engineers can guarantee that forklift can safely take maximum and uneven loads without tipping or structural failure when we study the structural analysis of the forklifts. Okay, so before this is the side view of the forklift. So this is the front view of the forklift. So we can see there are a few elements that we can calculate. So we can see there is a mass of the forks. The forks is where is the steel in front of the forklift here, at the below. So the long steel is called as a forks. So there's also a tires that will give also force, and then also the mass of the forks as stated before. So we will calculate how many maximum loads that the forklift can lift. So there are no tipping occurs when it arrive at a certain level. So when the forks, the steel one, is lifted until one level, so we will calculate how much is the maximum load.
I will talk about the free body diagram of the forklift that we have chosen for our project. Okay, as you guys can see, this is our free body diagram. All of the dimensions of the free body diagrams are in the unit of meter, which is M. Then we can see that the weight of the forks calculated is 1962 Newton. Then it has a normal force on the front wheel and the normal force on the rear wheel. Then it has normal force, which is NA on the front wheel and NB on the rear wheel. And then the size of the front wheel and rear wheel is not same, which we can see that the front wheel is bigger than the rear, so it means that the radius is not same for the front and rear wheel. It also has G, which is the center.
Okay, so for the rigid body part, we will be doing the calculation based on the free body diagram that have been explained by my friends previously. So we can see from the diagram, there are four forces, which is the WF, weight of the forks, G, the weight of the forklift, number 3 is the NA, the force acting on the front tire, and also lastly is the NB, the force acting on the back tire. Okay, so why we cannot assume that the front tire and also the back tire have the same forces? Because the sizes of the tire of the forklift is not same, so we cannot assume that the force is same for the front and also the back tire. Okay, so for the first two forces, which is the W force and also the G, we can see the calculation is at this part. So the mass of the forklift that we choose is 6,000 kg, because based on the journals, the forklift weight can vary until 8,000 kg. So we will be calculating the G. We will be multiply the mass of the forklift with the gravitational force, so we get 58,860 Newton, and also the mass of the forks is 200 kg, so we get the WF is 1,962 Newton. Okay, So next, before we determine the main focus, which is the maximum load, we need to find two unknown forces that acting on the forklift, which is the NA or also the NB. So we will be calculating the NB first by applying the moment equation about point A. So the equation is stated as here. So we can get our NB is 1962 Newton. Then after that we will be solving our NA. Okay, then the second unknown, which is the NA, we will be using the equation of the summation of forces Y axis. So we can get the equation as stated here, which is the NA plus NB minus G minus WF, because the G and the WF is on the negative direction, that's why it become negative. So we can get our NA, which is 5,800. Okay, now we already solve two unknown for the unknown forces acting on the forklift. So before we continue for the maximum load, we will be assuming that the forklift will remain no motion, so it will be static at one position only. So that's why there are no friction forces occur in our equation. Okay, lastly, our maximum load, which I rename it as L. So we will be using the moment equation about point A, but there is some assumption. To determine the maximum load L, we need to assume that there are tipping occurs where the load that we put on top of the forks will be tipping. So there will be tipping occurs when there are no normal forces on the rear wheels NA. So we can get our L is 2,102 Newton, which equal to the 214.29 kilograms. So from this calculation, we can show that the maximum load value is 2,102.14 Newton is bigger than forks mass, because we can go to the previous where we can see that the forks mass is only 1,962 Newton. So it shows that the tipping will occur. So to avoid the tipping from occur, the maximum load should be less than 2,102.14 Newton when the level of the fork is 7 meters from the ground of the warehouse.
Thank you, Jasmine. Now, my turns. My name is Nurhafizkah binti Razali. My metric number is KA23139. Let's continue to the last part in this presentation. This part is about the centroid for the forklift. As you can see here, this is the side view for the forklift. From this side view, we can create the free body diagram with the dimension needed to calculate this centroid. Your free body diagram will be like this. Before we start calculate, you must know some of the formula being used in this part, which is the area, the center of X, and the center of Y for all the section that being used. So, you can see here, this is the formula that will be used in this calculation. From the formula that we can calculate the center of forklift according to the segment as shown in free body diagram. We use table in this calculation to make sure our work are easy to understand and systematic. As you can see here, we can know the center of truck is 2.36 meter from X-axis and 1.96 meter for Y-axis.
In summary, throughout the planning project, questions about the project were resolved. The weight of the structure that we calculated using formula W equals to mg is 1962 Newton. FBD, all the measurements and the forces acting on the objects are shown clearly. And then we got maximum load L, which is 2102.19 Newton. Bigger than Fox mass, which is WF equals to 1962 Newton. Lastly, tipping will occur. To avoid tipping from occur, the maximum load should be less than 2102.19 newtons when the level of fog is 7 meters from ground of the warehouse.